So, a couple things. This is kind of in your notes, but it's listed in the text, and we're going to go through the notes line by line. But basic gist is the charge is a positive one for a proton, and instead of going by these weird masses over here with these very small numbers, 1.67 times 10 to the minus 24, that amount has been renamed as an atomic mass unit. So instead of trying to measure with lots of really funny scientific notation numbers, we're going to stick with a proton is 1 atomic mass unit, a neutron is 1 atomic mass unit, and an electron is basically 0. So we don't really need to concern ourselves with this column. But if you really were interested, they're very, very small values, just to let you know. We abbreviate the proton with a P+, the neutron with an N0, and an electron with an E with a minus sign because they're denoting their charges. A few things before we actually go in detail through the notes. But in each atom, there's something called a mass number. Mass number is always the protons plus the neutrons. The atomic number, which is the whole number on the periodic table, that atomic number, that's always the number of protons that the element has. So carbon is number 6 on the periodic table. That means every single atom of carbon is going to have 6 protons. That doesn't mean that every atom of carbon has 6 neutrons or 6 electrons. The only number that has to stay the same for carbon is the proton number. Carbon 14, which we'll show you in a minute, carbon 14 has 8 neutrons and 6 electrons. Okay. The mass number, this is in your notes, we'll go over it again, is always the protons plus the neutrons. That's what's in the center in the nucleus. And for a neutral atom, the protons equal the electrons. So if there isn't any charge on the atom, it's going to be equal numbers of protons and electrons. Now, if the atom gains or loses electrons, it's called an ion. We're going to go into that too. And we'll have to figure out their charges. Symbols. You're going to see symbols. We call this standard nuclear notation. Like I said, this is in your notes, but you might want to write this one down. I don't think this one's in your notes. The definition of an isotope. I know you've heard that word before because I know they teach it in physical science and all that. However, you might not remember. That's atoms of the same element that have different numbers of neutrons. The neutron number changes for isotopes. How can I tell it's an isotope? Well, I look here at my symbols. Here's an example. These are all carbons because they all have 6 protons. The bottom number next to the symbol, this one's always the atomic number or the proton number. The upper number on the left there is always going to be the mass number. Mass number, atomic number, which is also the number of protons. We use this standard nuclear notation to figure out protons, neutrons, and then if there's a charge, we can figure out the electrons. But if you look here at this example, carbon 12 is going to have 6 neutrons. 6 protons plus 6 neutrons gives you that mass number of 12. Carbon 13, though, carbon 13 has 7 neutrons because of 6 protons plus 7 is where we're getting that 13 from. And then last but not least, we have carbon 14, 6 protons, so that means we have 8 neutrons in carbon 14. So the 8 plus the 6 gives us that mass number of 14. Mass number is always what's represented in the nucleus. Okay? So isotopes, hopefully you wrote that down, when the atoms have different numbers of neutrons. When you have an ion, you're going to see a charge on the symbol. It'll have it in the upper right corner. An example of one with a positive charge and an example of one that has a negative charge. Okay? So, if I'm looking here, the sodium over here lost an electron. I know this because a regular sodium, how many protons does the sodium have? 11. protons. Now, a regular neutral sodium is going to have 11 electrons. But if I have a +1, that means I lost an electron and only have 10 now. Because I have one more positive than I do negative, I have a +1 charge. Now, of course, when it's just +1 or -1, they don't put a number by it. You'll just have a plus or minus because it's an understood one, like in math. Like you don't put 1 in front of x, right, if it's just x. Same idea here. But if it's more than 1, they will give you an actual number here, like this one. This means that the boron gained 3 electrons. Okay? Gaining electrons, because electrons are negative, that's going to mean your charge is going to be negative. So, boron has how many protons? 5 protons. It normally starts with 5 electrons. But if I have a -3 charge, that means I gained 3. So my electron number now is 8. So I have 3 more negatives than I do positives. So my entire charge is a -3. Now these charged atoms that are ions, those charges allow them to bond with other atoms with charges because those opposites attract. That's called an ionic bond. We'll get to that later. But you've probably heard of ionic bonding back from 8th grade. So a couple definitions to write down on the notes because I know they're not in there. Ions. Atoms that have gained or lost electrons. Now there's 2 types, and please say these correctly. This is called a cation. It's not a cation, it's a cation. Okay, cations are ones that lose electrons and have positive charges. A good way to remember that the cation is the positive one is the fact that there is a T in here. What does a T resemble? A plus sign. So if you can remember that one has the T, you know it's the positive one. It means it lost electrons. Okay? That's a good way to remember the cation's the positive one. And this one is an anion. A negative ion. We like to say that too. That kind of is a way to remember that one. That means the atom has gained electrons to become the negatively charged ones. So for example, you can always figure out the charge if you do the protons minus the electrons. If they give you the electrons, you can just subtract it and figure it out. But say I have an oxygen atom. If I look at my periodic table, I know that oxygen is going to have 8 protons. Okay? Most oxygens are 16, so I'll just write that down as the mass number for fun. But if I have 10 electrons, I normally only start out with 8 electrons. So if I have 10 now, that means I've gained 2. When you've gained 2 electrons, that means you have 2 more negatives than you do positives. So my charge on here would be a -2. Now, you can write the charge with the minus in the front. You can write the charge with the minus in the back. At this point, it really does not matter which way you write it. Aluminum, on the other hand, aluminum's number 13 on that periodic table. Okay, Al has a 13. And its mass is mostly 27, so we're just going to go with that. But if we have 13 protons normally to start with, that means we have 13 electrons normally to start with. So if we only have 10 now, 10 electrons, that means we've lost 3. You lose 3 electrons, that means you now have 3 more positives than you do negatives. So your charge ends up being a +3. Okay, so those are a couple of examples of how to do the ions, and we're going to do a bunch of examples, maybe not today, but hopefully Monday. Now sticking to your notes. These are the notes that you have, so you might want to underline the important stuff that I've already gone over. This is going to reiterate, go over again, the important things like positively charged particle. We always do the P with the plus sign there. It equals 1 atomic mass unit. That's very important. You need to know that. It's located in the nucleus. It identifies the atom, the element. So if I have 12 protons, I'm always going to be a magnesium, because magnesium's atomic number is 12. So it doesn't matter what the neutrons are, doesn't matter what the electrons are. If I have 12 protons, I'm automatically magnesium. So it's also the same as your atomic number, so make sure that you know that. That's the most important thing, identifier. Electrons are negatively charged. We abbreviate them with the E minus. They're very small. Like I said, the mass is basically 0 or negligible. And it equals the protons if we're neutral. It has a +5 and a -5. Guess what? That adds up to 0. Or a +10 and a -10 adds up to 0. So if you have equal number of protons and electrons, you have equal numbers of each charge, and therefore you should have 0. The charge size is equal and opposite to the proton. So protons a +1, electrons a -1, they balance each other out. So this is the first set of your notes there. Second set of your notes there is the neutron notes. The neutron is that N0 because it does not have a charge. It is the same mass as a proton. It's 1 atomic mass unit. Okay, it only adds mass to the atom. It doesn't have a charge or anything. It's found in the nucleus, as you see in the picture over here. And one other quick term that you might see occasionally, we don't use it that often, is nucleon. Nucleon's basically just talking about what's in the nucleus. Well, always in the nucleus are the protons and the neutrons, never the electrons. The electrons are always in the cloud. Now understanding the numbers on your periodic table. The ones on yours look maybe different than this one up here. It doesn't matter where they put it inside the block though. The whole number is always the atomic number. So wherever it is in the block, the atomic number is always the whole number. The symbol is always going to be denoted with a 1-letter or a 2-letter combo. The first one's uppercase, the second one's lowercase, though if it's the 2-letter combo. The decimal number, the decimals number is always the average atomic mass. Now the average atomic mass is slightly different than what we would say a mass number is. The average atomic mass is a weighted average of all the isotopes of that particular element. Whereas if I'm giving it a mass number, I'm talking about one particular atom in that group. So mass number is on an atom. The average atomic mass is for all the atoms of that element. Okay, so it's similar to, but it is not the mass number. The only time you get to use the atomic mass, the average atomic mass, is if the mass number is not provided for you. If the mass number is not provided to you in some kind of shape or form, you can round the atomic mass and get a mass number. But most of the time it will be provided in the notation with the symbols, or it will be provided to you in a chart with data. Standard nuclear notation up here, using the symbol and the different numbers. Upper left corner is always the mass number, lower left corner is always the atomic number or protons. Upper right corner is always going to denote a charge. If there's nothing in the upper right corner, that means the charge is 0. It's understood 0. If there's no charge there, it's an understood 0 neutral atom. 66 in this particular case is the mass number. 29 is the atomic number. So this copper has, well, always going to have 29 protons, but its mass, you would do 66 minus the 29 to figure out that it has 37 neutrons. 37 neutrons. Okay, as you go up the periodic table, the neutron numbers become bigger. You'll see as you get down to like uranium, which has protons of 92, but the mass number is 238 or something like that. That's a lot of neutrons. The +2 means that we lost 2 electrons. So if there are 29 to start with, because there's 29 protons, That means we lost 2, so now we have 27 electrons. So always look to that proton number to figure out how much electrons you should start with, and then decide from there which way to go. Mass number is always the protons plus the neutrons. This is on your sheet here, so you can write that, just circle that. Okay? If you're given the mass number and the atomic number, you can always figure out your neutrons by working backwards. Subatomic particles, work backwards, you can get that information. Now we're going to do a few examples in our chart here. And I want you to switch this one. It was a typo. Make sure that says mass number, not atomic mass. So you're going to be given charts like this to fill in and use the information to figure out how many protons, what's the atomic number, how many electrons, and so forth. So I have to look over here at what information they give me. So in this particular case, the only thing they're giving me is the symbol with the nuclear notation. So we have a fluorine atom. What's its mass number? 19. Its mass number is 19, so I'm going to put that in here, 19. What's its atomic number? 9. Okay. The atomic number also tells me another one. The protons. So these two, the protons and the atomic number should always match. Should always be the same. Now, does that one have a charge in the upper right corner?
No.
No, it does not. So we assume we're at 0. We're neutral. It's an atom. So if I have 9 protons, that means I have to have how many electrons? We must have 9, because for every positive, we must have 1 negative to cancel it out. So the electrons must be 9 as well, because there's no charge on there. Now, how do I figure out my neutrons? I take my mass number, which is 19. I subtract my protons, and that's going to tell me I have 10 neutrons. Now this is where you have to be able to pull out that periodic table, because this one doesn't tell me which element we're dealing with. Instead, I have to look up what on the periodic table. The atomic number. And this happens to be chlorine. Very good. This is chlorine. So I'm going to put my symbol here. And it tells me my atomic number is 17. So what should I put in my lower left corner? A17. It also tells me my mass number is 30. So what should I put in my upper left corner? 30. Very good. We're getting there. Now, it tells me I have 18 electrons. What happens there? What does that mean? Well, how many did I start with? If I'm neutral chlorine, how many do I have?
17.
17. Good. So 18 means I gained 1, right? So what kind of charge am I going to have, a positive or negative?
Negative.
Negative. Gaining a negative charged particle means you're going to be negative, right? So this is going to be a -1. So I'm just going to put a negative up here. However, okay, this is not technically wrong if you write a -1 like that. But if it's only 1, the negative sign is understood as a 1. So you might see it with just the negative sign, that means understood 1. Now for our neutrons. We're going to do 30, which is the mass number, minus 17, so that would be 13. Very good. Oh, let's look at the last row here. Where do I start there?
By finding the...
They give me the protons, gives me the electrons, it gives me the number of neutrons.
Atomic numbers.
The atomic number is 8, so what element are we dealing with? Oxygen, good. Now, how do I figure out my mass number? What's in the mass number? Neutrons, yes. What else is in the mass number?
Electrons. Protons.
Who's in the nucleus? The protons and the neutrons. So we're going to add those two together to get our mass number.
18.
So 10 plus our 8 gives us 18. So now I can fill that in, my 18. Now let's look at our electrons. How many electrons? 8. So if I have 8 protons and 8 electrons, what's my charge? 0. So do I need to put anything at the upper right corner?
No.
No, I leave it blank. That's exactly right. Yes. For the mass number, 10 neutrons plus 8 protons gives us 18 for the mass number. Because with what's in the center of the atom, what's in the nucleus, is always going to be the protons and the neutrons together. That represents the mass. If you think about it, protons are 1 atomic mass unit, neutrons are 1 atomic mass unit, so they're the only ones that really give mass to the atom at all. The periodic table says 16 because the weighted average is closer to 16. So, this is an isotope of oxygen that has 2 extra neutrons than the normal mass, which would be 16. That is a weighted average of all the isotopes of oxygen. Most of them have 16, but there are a few out there that don't. So remember that decimal number is not really for a particular atom. That's for all the atoms of that particular element averaged together with their percent abundances. Let's get out your periodic table. On the atom worksheet side, it asks for a group and a period number. If you look at your periodic table, you should be able to figure out what a period is. You should be able to figure out what a group is. But just want to make sure that you can see that there. So, what do you think the periods are? The rows. Good. The periods go across. They are the rows. Periods are the rows on the periodic table. If you see period, that equals a row on the periodic table. Now, what is a group then? Groups equal the columns on the periodic table. So when you're looking for that information, realize that the rows are the periods and the groups are the columns. Okay? So if you want to write that down real quick, just a quick little note in doing that assignment.